Hi students, this is Viswanath, Chemistry faculty for NEET and IIT exams. In last class we completed numericals related to enthalpy of neutralization. Now see the next one. Given enthalpy of ionization of HCN equal to 45.2 kilojoule per mole and enthalpy of acetic acid is 2.1 kilojoule mole inverse. Which one of the following is true? Okay, so HCN is a weak acid and CH3COOH is also weak acid. Between these two, which compound having more pKa value and less pKa value we should find out. Say this: if for an acid enthalpy of ionization is more, then that compound has less acidic nature. Here enthalpy of ionization means the heat energy required to ionize an acid. Generally acids on ionization produce H plus ions. So to give H plus ion, more energy is required means H plus ion donating capacity is less. That means they have less acidic nature. For those compounds, pKa value is more. Same thing we mentioned here. For an acid, enthalpy of ionization is more, then that compound has less acidic nature. In that case, pKa value is more. Now, enthalpy of ionization of HCN is 45.2. For CH3COOH is 2.1. For hydrocyanic acid, more energy is required than acetic acid. That means this compound having less capacity to donate H plus ion than CH3COOH. So acidic nature is less means pKa value is more for HCN. Then what is the suitable option? pKa of HCN greater than pKa of acetic acid. So option B is the answer. I hope you understood the explanation. Next, see the next question. Calculate the heat of neutralization from the following data. 200 ml of 1 molar HCl is mixed with 400 ml of 0.5 molar NaOH. The temperature rise in calorimeter was found to be 4.4 degrees Celsius. Water equivalent of calorimeter is 12 grams and specific heat is 1 calorie per ml degree for solution. Okay, here heat of neutralization or enthalpy of neutralization we should find out. HCl is mixed with NaOH. Molarity, volume of HCl and NaOH are given and temperature rise is also given. Say this: given total solution HCl is mixed with NaOH means HCl volume 200 ml, NaOH volume 400 ml. Total solution volume is 600 ml, 200 plus 400. Now 200 ml of 1 molar HCl neutralize 400 ml of 0.5 molar NaOH. In this case, according to neutralization, enthalpy of neutralization definition, gram equivalents we want. Volume is given in milliliter, so calculate milli equivalents. Milli equivalents equal to normality into volume. Milli equivalents of acid equal to normality and molarity. Here in the question, in the data, molarities are given. We want normality. What is the relation between normality and molarity? Normality equal to molarity into n factor. For HCl, n factor is 1. So normality means molarity 1 molar into n factor 1 into volume in milliliter 200. That equal to 200 milli equivalents. Milli equivalents of base, same molarity 0.5 into what is the base here? NaOH. For this n factor 1 into volume in milliliter 400, that equal to 200 milli equivalents. So here milli equivalents of acid and base both are same, that is 200. That means 200 milli equivalents of HCl react with 200 milli equivalents of NaOH to produce heat, that is delta H. Now 1000 milli equivalents of HCl plus 1000 milli equivalents of NaOH will give heat energy, that is 5 into delta H, because here 1 gram equivalent we should calculate. 1 gram equivalent means 1000 milli equivalents. So for 200 milli equivalents of neutralization reaction, delta H means 1000 milli equivalents of neutralization reaction, how much heat energy is released? This 1000 milli equivalents is 5 times to this. That's why heat energy released is also 5 times to this. So 5 into delta H. Now we should calculate this delta H. Say this. That is nothing but heat of neutralization. Now delta H, heat produced during neutralization of 200 milli equivalents of acid and base, equal to heat taken up by calorimeter plus solution. So during the reaction, heat energy is released, that is absorbed by the calorimeter. To calculate that heat energy, formula is M1S1 into delta T. M means equivalent of the calorimeter, 12 grams. S means specific heat, 1 calorie per ml degree. Delta T, temperature rise 4.4. Here M2, total volume of the mixture, how much? 600 ml. Specific heat 1 into temperature rise 4.4. From this we can get delta H 2962.8 calorie. So heat of neutralization equal to, here heat is released, so we use the sign minus. Minus 5 into delta H equal to this one. Finally we can get minus 13.464 kilocalorie. Okay. See the next one. Hess's law of constant heat summation. The heat energy released or absorbed in a chemical reaction is same whether the reaction occurs in one step or several steps. Now consider a general reaction. A gives rise to D. A is the reactant, D is the product. This reaction may take place in different steps. A change it to B, B change it to C, C change it to D. In each step, some amount of heat energy is released. This heat energy is the same whether the reaction takes place in single step, that is A gives rise to D, otherwise different steps. So that is called Hess's law of constant heat summation. This law is applicable for both physical and chemical processes. Hess law is an application of first law of thermodynamics or law of conservation of energy. Remember this point carefully. Generally students may get confusion. Hess law is an application of first law of thermodynamics or law of conservation of energy. Next, second law of thermodynamics. It is not given in the NCERT syllabus, but for IIT exams it is required. So this second law of thermodynamics we can mention in different ways. See them. Heat cannot flow from a colder body to hotter body on its own. Generally, heat flow takes place from hot body to cold body. Keep a cup of coffee, hot coffee in the outside atmosphere. After some time, it will become cool. That means from that hot coffee, temperature is transferred to the surroundings. So temperature transferred from higher region to lower region, hotter body to colder body. But if we want to observe the heat flow from colder body to hotter body, it does not take place on its own. Suppose if we want to transfer the heat from a cold body to hot body, we need some external assistance. Then only that transfer is possible. So that is second law of thermodynamics statement. Next one, all spontaneous processes are thermodynamically irreversible. Spontaneous processes means the process which takes place on its own without external assistance, that is called spontaneous process. Example, flow of heat from hotter body to cold body and flow of water from hill area to ground and wind flow from high pressure region to low pressure region. All these are spontaneous processes. Some chemical reactions, if we combine reactants, they can start reaction and form the products. So all these are spontaneous processes. These are irreversible. Once reaction takes place or process takes place, we cannot get back the original substance. So all spontaneous processes are thermodynamically irreversible and entropy of the system increases. Students, entropy, it will come next topic. Entropy means simply the disorderness of a system. The disorderness of the system always increases. That is second law of thermodynamics. See the next one. It is impossible to construct a machine working in cycles and transfers heat from a lower temperature region to a higher temperature region without intervention of an external agency. Just already in the first statement we completed same thing. So if I want to construct a machine which works to transform heat energy from low temperature region to high temperature region, is not possible without intervention of an external agency. Without the help of external agency, we cannot transfer heat energy from lower region to higher region. That type of machine we cannot construct. With the help of external agency only, we can transfer heat from lower temperature region to higher temperature region. Next, another statement. Heat cannot be converted into work completely without causing some permanent changes in the system or in the surroundings. Now we want to convert heat into work completely. Then some changes should be takes place in the system or surroundings. Then only that conversion is possible. Otherwise, we cannot convert heat into work completely. That means definitely in the conversion of heat into work, some amount of that heat causes permanent changes in the system or surroundings. This is also another statement for second law of thermodynamics. Okay students, practice well. We'll meet you in the next class.